Okay, so you're scrolling through your favorite app and bam, you've got some new recommendations. Or maybe you're dealing with a chatbot on a website trying to get an answer to a question.
Right, and you know what's powering those experiences.
AI is
Yeah,
everywhere.
it really
But
is.
here's the thing.
Yeah.
How do we make sure this AI is actually being used responsibly? And that's what we're diving deep into today.
Responsible AI practices.
Exactly. And we're going to break down what that means practically for you.
So we've been digging into a bunch of really cool discussions on this topic. And for this deep dive, our aim is to pull out the most important things about making AI fair, understandable, and really reliable. And we also want to see how this connects to all the rules and guidelines that are popping up around AI right now.
Yeah, because there's a lot of talk about that.
There is.
But this is really about making this relevant and clear for you. So, okay, responsible AI practices. It sounds nice in theory, but what does that actually look like when someone is putting this into practice?
So at its core, responsible AI is about thinking about more than just how well a machine learning system performs from a technical standpoint.
Right.
It's about considering ethical and legal aspects all the way from the very beginning when you first have the idea for a project, all the way to when you actually use the AI.
So it's not just about, like, does the algorithm work?
Exactly. It's also about making sure you're operating within the law, like the GDPR,
Right.
which sometimes, gives people the right to understand how an automated decision was made about them. And we're seeing even more new regulations coming up like the EU AI Act that are going to change how AI is developed and used even further.
Yeah, these are big changes.
They are big changes.
And then there are organizations like Google and their PAIR initiative or IBM's AI Fairness 360.
Exactly. They're offering some really practical advice and frameworks.
Yeah.
So it's becoming a more and more structured field.
It's interesting how there's both like the big picture stuff that is happening and then these very specific things. Can you give me a few like concrete examples of what this actually looks like?
Absolutely. So a big part of it is being super careful about the data we feed these AI systems. We want to make sure that the data isn't biased in a way that could lead to unfair outcomes.
Right.
And then if an AI makes a decision, like say it rejects someone for a service,
Right.
we need to understand and sometimes even explain why that decision was made.
Yeah. Especially if the regulations say so.
Especially if the regulations say so. And importantly, the AI needs to be robust. It shouldn't just break down or give you weird results if it encounters slightly different data than what it was trained on, or if someone's intentionally trying to mess with it.
Like it shouldn't break if someone sneezes.
Exactly.
Okay, so this is not just a one-time check the box kind of thing.
No.
It's more like an ongoing effort.
Totally an ongoing effort. It involves constantly checking to make sure the AI is still doing what it's supposed to be doing and that it's aligned with our responsible AI goals.
Right.
And it also means talking to the people who might be affected by the AI and keeping really detailed records of how the system was built and how it's being used. You've got to always be thinking about the bigger societal impact.
So let's get into this idea of fairness a little bit more. How do you go about building an AI system that you can actually say is fair? Because it feels kind of like an abstract goal.
It can seem that way, but there are some very specific things we can do. And it often starts way early in the process when we're collecting and preparing the data. We do something called a bias audit.
A bias audit.
Yeah, and that means we're really examining the data using things like exploratory data analysis and visualizations. We want to uncover any potential problems or imbalances right from the get-go. We might even use special tools to help us profile the data to understand its characteristics.
Right.
And we might use some open source libraries, like Pandas profiling.
Oh, yeah.
Yeah,
They're popular.
they are.
So you've looked at your data. How do you then determine if the AI you've trained on that data is actually fair?
That's where we use specific metrics to measure fairness. We have target ranges that we want these metrics to fall within. For example, there's the statistical parity difference, which looks at the difference in outcomes between different groups.
Right.
Our goal might be to keep that difference under 5%. Another one is the equal opportunity difference, which focuses on making sure that the true positive rates are similar across all groups.
Okay.
We might aim for no more than a 3 percentage point difference there. And then there's the disparate impact ratio, where we want the ratio of positive outcomes for different groups to be pretty close to 1. And we usually get worried if it goes much outside of the range of 0.8 to 1.2.
You guys are really specific with the numbers there.
Yeah, we have to be precise.
Can you give me a real-world example where you might have to, like, make a trade-off when it comes to these metrics?
Sure. Let's go back to that credit scoring model we talked about earlier. We might find that the first version of our model has a disparate impact ratio of 1.8 for a certain demographic group.
Okay.
And to bring that down to a more acceptable 1.2, we might actually have to tweak the model. And that might mean the overall accuracy of the model drops a little bit, maybe by about 3%.
Okay.
And that brings up a really important point. If we just focus on making the model as accurate as possible, that could actually end up making existing inequalities worse,
Wow.
right? So we have to make a choice. Do we prioritize fairness even if it means the model is a tiny bit less accurate overall? This isn't just a technical decision. It reflects what we value as a society.
So you're deliberately choosing to make the model slightly less accurate so that it's fairer to everyone.
Exactly. And to help us achieve this, we use special toolkits like IBM's AI Fairness 360, which gives us different algorithms and techniques. We might also use things like reweighting the data, where we give more importance to data points from groups that are underrepresented.
Right.
Or we might use SMOTE, which helps us create synthetic data points to balance things out.
And this isn't just a one-time check.
It's not a one-time thing.
You're constantly looking at it.
Once the model is up and running, we've got these dashboards that use tools like MLflow to track our experiments. And these dashboards are always keeping an eye on those fairness metrics. If any of them go outside of the limits we've set, we get alerts through systems like Prometheus and PagerDuty.
Yeah, I've heard of those.
And then our data engineering team can jump in and figure out what's going on. We usually aim to address these issues within about 6 hours.
So you mentioned equal opportunity, and then you also mentioned equalized odds, and those sound really similar.
They do.
What's the difference?
There's a subtle but important difference. Equal opportunity focuses on making sure the system has a similar, true positive rate for different groups. So imagine a system that's trying to identify who should get a certain benefit. Equal opportunity means that the system is equally good at correctly identifying eligible people from every group. This is really important when missing a positive case could have bad consequences for the individual.
Okay, I got it. What about equalized odds?
Equalized odds goes one step further. It wants not only equal true positive rates, but also equal false positive rates.
So it's more balanced.
It's about balance. So in our benefits example, this means the system isn't just good at identifying eligible people from all groups, but it's also not incorrectly flagging ineligible people at different rates for different groups.
Can you give me an example of when you might choose one over the other and what the trade-offs might be?
Sure. Let's think about that loan approval model again. If we're really focused on equalized odds, meaning we want to reduce both unfairly denying loans and unfairly approving loans to those who will default at the same rate across the board,
Yeah.
we might see that the overall performance of the model, as measured by something called AUC, might drop a bit,
Okay.
maybe by around 5%. EUC is a way we measure how well a model can separate two classes.
Right.
But getting equalized odds might lead to something really good, like a 15% reduction in the number of people from marginalized groups who are unfairly denied loans. So it's a balancing act.
Wow, yeah.
Is it okay for the overall accuracy to dip slightly if it means we're significantly reducing unfair outcomes for certain groups?
Yeah, it's a big decision.
It is a big decision. We use simulations and we do cost-benefit analyses to make these decisions.
Wow.
We always have to think about the ethical implications, the regulatory requirements, and how the model is going to perform in the real world.
These AI models, they can be so complex. People call them black boxes. How do you even start to understand why they're making the decisions they do?
That is a huge challenge, but it's really important for building trust and making sure AI is being used responsibly.
Yeah, how do you do that?
So for these more complicated models, we use what are called model-agnostic interpretability tools. Two of the most popular ones are Lime and Chap. Lime looks at a specific decision the model made and then sees how the prediction changes if you tweak the input data around that specific case.
Right.
So it's creating a simpler local explanation for that decision.
Okay.
Chap, on the other hand, uses game theory to figure out how much each input feature contributed to a particular prediction.
So like assigning a value to each piece of information.
Exactly.
You mentioned earlier that Lime can sometimes be unstable. What does that mean?
Yeah, so in some situations, especially with unusual data points, or if you change the input in a slightly different way, the explanations that Lime gives can change a little.
Oh, interesting.
We've seen cases where the feature importance scores jump around by more than 20%. So for a more consistent picture, we often use Chap, which tends to give more stable results. And sometimes we use another technique called anchors.
Anchor.
Anchors try to find specific conditions or combinations of features that always lead to the same prediction. And in our own testing, using anchors along with Lime and Chap increased our stakeholders' confidence in the explanations by about 40%.
That's a big jump.
It's a big jump.
So you're not just blindly trusting these explanations.
Definitely not.
How do you make sure that these explanations are actually giving you useful information about the model?
We have to validate them. One way we do that is by training a simpler model that's easy to understand, like a decision tree.
Okay.
And we use it to try to copy the behavior of that complex black box model on a separate set of data that the original model hasn't seen. Then we compare the predictions of the simpler model to the black box model and measure what we call fidelity. We want a high level of fidelity, usually at least 92%, because that tells us that the simpler model is doing a pretty good job of showing us how the complex model is making its decisions.
Okay, let's shift gears and talk about robustness for a minute.
Okay.
What does it mean for a model to be robust in the world of AI?
Robustness is basically how well the model keeps performing, even when it encounters real-world data, which could be messy, unexpected, or even intentionally misleading.
Right.
A robust model shouldn't be easily thrown off by small changes to the input or by someone deliberately trying to trick it.
So how do you check how robust a model is? What kinds of tests do you run?
We run a bunch of tests. To simulate the kind of noise you might find in the real world, we might add random noise to the input data,
Okay.
things like Gaussian noise or salt and pepper noise, and see if the model's performance drops significantly.
Right.
We also do what are called adversarial attacks.
Okay.
We use algorithms like FGSM and PGD to find tiny, almost undetectable changes to the input that could cause the model to make the wrong prediction.
So you're trying to find the model's weaknesses.
Exactly.
What about when a model's performance starts to go down in the real world because the data it's seeing is changing over time? How do you know that's happening?
We're always monitoring the characteristics of the data coming into the model. We use statistical tests like the Kolmogorov-Smirnov test or KS test to compare the distribution of the input features to the distribution of the data the model was trained on.
Right.
We have tools like Evidently AI to do this automatically,
Okay.
and it alerts us if there are big changes in the data patterns.
You mentioned earlier that you had a situation where you noticed a shift in user behavior data. What happened there?
Yeah, so we saw that users were interacting with one of our systems in a different way.
Okay.
Our monitoring systems picked up on that, and we started a process to retrain the AI model. We used AWS SageMaker pipelines to automate this retraining so we could include the new user behavior data.
Got it.
Being proactive like this really paid off because we saw a 30% drop in the error rates once the model was updated.
Nice.
Yeah.
Can you give me a more detailed example of a time when a change in data really impacted a model in production?
Sure. So we had this model that was analyzing the sentiment of social media posts, and it was trained on a massive data set of historical data. But then a major global event happened,
Oh, yeah.
and the way people were expressing themselves online completely changed. Our monitoring system quickly showed us a 10% drop in the model's F1 score, which is a key measure of how well a classification model is performing.
So what did you do right away?
The first thing we did was pause any automatic updates to the model. Then we launched a full-on investigation to understand what had changed. We used the KS test with Evidently AI to pinpoint exactly what parts of the language had shifted.
Okay.
Then we did something called dynamic weighting in our model's learning process, which basically tells the model to pay more attention to the newest data when it retrains. We also grabbed fresh, real-time social media data from our APIs, and we retrained the model regularly every 2 weeks using AWS SageMaker pipelines. This allowed us to adapt quickly to the new ways people were using language, and we managed to bring the model's performance back to where it should be, and we even reduced the error rate by 30%.
So you can't just build a responsible AI system.
Right.
You have to maintain it.
You have to maintain it.
What does that look like?
So maintaining a responsible AI system in production involves doing a few things.
Okay.
We have continuous monitoring built into our systems.
Okay.
We have real-time dashboards that use things like MLflow to keep an eye on key fairness metrics like equal opportunity differences and disparate impact ratios, and also our robustness scores.
Wow. Okay.
We also have automatic alerts set up using Prometheus and Grafana,
Got it.
and those tools are constantly checking our metrics against what we've seen historically. And if any metric goes outside of the acceptable range, they'll send a notification through PagerDuty to the on-call engineers.
So what happens when you get one of those alerts?
We've got a clear process for responding to them. There's an escalation path, and our engineers have a goal of fixing the problem within 6 hours. On top of all this monitoring and responding, we also do more in-depth audits every 3 months. These audits involve a whole team of people, data scientists, legal professionals, and ethicists. They review detailed reports and all the relevant documentation to make sure we're still following all the rules like GDPR and CCPA.
It sounds like a lot of teams and different things to think about.
It is a lot.
How do you make sure everyone is actually following these responsible AI principles, especially when there's pressure to launch things quickly?
Having solid governance structures in place is crucial.
Okay.
I really suggest creating a special AI ethics committee
Okay.
that has a clear structure and a mandate. This committee should ideally include a diverse group of people, data scientists, ethicists, legal experts, and folks who really understand the specific area where the AI is being used.
So what kind of authority should this committee have?
This is a big one. This committee needs to have the power to stop a model from being deployed if it doesn't meet the standards for fairness and robustness.
So they can say no.
They can say no. We had a case where a model for scoring potential sales lead had a disparate impact ratio of 1.7, which the ethics committee said was unacceptable. They went straight to our CTO, and the model's deployment was put on hold for 3 months until the fairness issues were fixed.
Wow.
This really shows how important it is to have a group that can prioritize ethical concerns, even if it means delaying a project that's important for business.
Absolutely. So beyond the technical side of things, how do you handle potential biases when you're first collecting the data?
That's fundamental. It starts with really digging into the data using exploratory data analysis techniques. We use statistical tests like chi-squared tests and a bunch of different visualizations to find any weird patterns or potential biases in the data.
Okay.
We also use methods like stratified sampling to ensure that all the different subgroups are represented proportionally to how they occur in the real world.
Right.
If we find that certain groups are underrepresented, we might use techniques like reweighting to give their data more weight when we're training the model. And if some groups have very few examples in the data, we might even use SMITE to create synthetic data points to help the model learn better from those groups.
So what role do the experts in the specific field play in all of this?
They're super important. They can look at how the data is being labeled to make sure it's accurate and consistent. They can point out biases that might be specific to their field and not obvious from just looking at the data.
Right.
And they can give us advice on things to avoid during data collection and sampling. For example, in a healthcare application we were working on, the advice from medical professionals was really crucial for adjusting our sampling strategy to accurately reflect how common rare conditions are. This made the model more accurate and fairer overall.
So even with all these precautions, sometimes models still run into problems in the real world because data changes in unpredictable ways.
It happens.
What's your process for handling those situations?
If a model in production starts to act up, we've got a structured plan.
Okay.
First, we stop any more automatic updates to the model. Then we investigate to find the root cause.
Okay.
We look at charts of key metrics like accuracy F1 score and our fairness metrics to pinpoint exactly when and how much the performance dropped. We also check things more often, maybe hourly instead of daily.
Right.
And we use tools like Evidently AI that can automatically detect anomalies.
Got it. So what happens once you know what the problem is?
We get fresh data, often through real-time data streams, and we factor in feedback from users. Then we retrain the model using systems like AWS SageMaker pipelines. This helps us minimize any downtime, and we can quickly incorporate the new information. And finally, we send a detailed report to everyone who needs to know explaining what happened. For example, we might say that the F1 score dropped by 10%, and we'd outline everything we've done to fix it.
So you're aiming to have everything back to normal in 6 to 8 hours.
That's the goal.
It all sounds really important, but for people who aren't techie, it can be hard to see the value of all this.
That's a great point.
How do you explain it to people who don't have a technical background?
The trick is to connect these efforts to real business outcomes that everyone understands.
Okay, yeah.
For example, we can show how we made a customer support model less biased, and that led to a 50% drop in customer complaints, which saved us a ton of money on support costs. In one case, it was like $500,000.
Wow.
Yeah. We also use clear visuals to show how following rules like GDPR directly reduces the risk of getting hit with fines. And when we talk about robustness, we frame it as a way to protect our reputation and avoid losing money from things like data breaches or PR disasters.
Right.
In one case, this helped us get a 20% bigger budget for security testing, which ended up preventing potential losses of up to $2 million during a security incident.
Wow.
By constantly connecting our technical work to its financial impact, we can show that responsible AI isn't just the right thing to do, it's good for business too.
It's super clear from everything we've talked about today that responsible AI is so much more than just a buzzword. It's a set of vital practices that anyone building or using AI needs to think about. We've gone through how to make AI fair, how to understand those complex models, and how to make sure it stays reliable in the real world.
Exactly. And like we've discussed, this isn't just theory.
Right.
It's about using the right tools, tracking the right metrics, and being committed to constantly improving things.
Yeah.
For everyone listening, this should give you a solid grasp of the key principles that are shaping the future of AI.
And as AI keeps advancing at an incredible pace, it really makes you think, how do we balance that rapid progress with the crucial need to implement it responsibly?
It's a question we all need to ask ourselves.
It really is. What role do you see yourself playing in all of this? Think about what these principles mean practically, both in your professional life and in your everyday experiences with AI. It's definitely something worth pondering.
For sure.
Well, on that note, that's our deep dive into responsible AI practices. Thanks for joining us.
Thanks for having me.
We'll see you next time.
See ya.